This is a video to show you how to solve absolute value equations. We'll do another video for inequalities. I provided a cutout from the textbook, but I'm going to be honest with you, it's a little difficult to understand. It gives you a full formal definition of how and why we're solving absolute values the way we do. If you read through this and understand it, great. It comes to a conclusion here that when you have an absolute value expression, it can either equal negative C or positive C. That's kind of the bottom line. So I try to insert a little sentence here to help you just think about it in plain English. Since the absolute value is distance from zero, the absolute value of negative 6 is positive 6, and the absolute value of positive 6 is positive 6. So the negative is coming into place up here because how do you turn a negative 6 into a positive 6? You multiply it by negative 1. Bottom line for you guys is when you're doing absolute value equations, you're going to have two equations to solve, once for the positive distance from zero and once for the negative distance from zero. You can see it in the absolute value function as well. Part of the function is positive x, part of the function is y equals negative x. So there's a positive and negative component. Of course, the absolute value flips it to distance, which is always positive. There is an example written out for you on your notes where it shows that you have to isolate the absolute value part of the expression or the equation first. This equation has a 2 multiplier in front, an a value. It has a -5, but we need to isolate the absolute value. So it goes through the steps by adding the 5 to both sides, dividing the 2 out, and making sure your absolute value part is isolated completely. Once you get the absolute value isolated completely, then you're going to solve two equations, not just the one you see. You're going to be able, once you get the absolute value isolated, you can remove the absolute value bars as long as you set the equation up once to +3 and once to -3. When you find your solutions, it's imperative that you check your answers. You've got to plug them back in and check your work. And in some cases, you're required to do a number line. I think it's a little silly to put your single points on a number line. So these kind of solutions where you box in your x values are fine. All right, I'm talking fast because it's a video. You can slow down and rewind. You can also look this over. Let me work through a few with you guys to kind of show you the process. All right, the first one I have is a fairly simple absolute value equation. Sorry if it's a little blurry. X minus 2 in absolute value is 3. This is telling me the distance of the expression x minus 2 is 3 units away from 0. The absolute value is isolated. There's no multipliers, no addition or subtraction. It's all by itself on the left side. So once the absolute value is isolated, then you can solve your two equations. Your first equation is x minus 2 equals +3, just like you see here. And your second equation is x minus 2 equals -3. We have to consider the positive distance from 0 as well as the negative distance from 0. Once you get that, they're fairly easy equations to solve. Of course, I'm going to add 2 to both sides. This one gives me x equals 5. If I add 2 to both sides here, be careful with the negative. X is -3 plus 2 is -1. So I have x could be 5 or x could be -1. You want to make sure to check your work. So we're going to take a 5 in. 5 minus 2 is 3. That one checks out. -1, if you plug it in, -1 minus 2, this one would give me inside absolute value -1 minus 2. And does that equal 3? I'll put a question mark because I'm checking. Make my bars a little bigger. -1 minus 2 is -3. And the absolute value of -3 is 3. So that one checks out as well. You have to check your answers to make sure they work. But once they do, you can box these well. You know what? I'm going to be good and write a separate line that x equals 5. And I'm going to go ahead and put an and here because both solutions work. X equals -1. You could get away with an or statement since both answers will make the equation true, or either answer will make the equation true, but these are both solutions for it. So I'm going to put an and there. All right, let's try this one that has some extra stuff in it. In other words, my absolute value is not isolated in this one. In this case, I need to add 4 to both sides because I need to isolate the absolute value. I get the absolute value of x plus 1 is equal to negative 2 plus 4, or 4 minus 2 is 2. Once you get the absolute value isolated, you're ready to write your two equations. Remember, your first equation is absolute value of x plus 1 equals positive 2. You basically just remove the absolute value bars and write what you see. The next equation has the bars removed. I'm going to go ahead and put an and in between since we decided on that word. X plus 1, whatever's inside the absolute value, you set it equal to the negative distance from 0. So one's to the positive, one's to the negative. They're not hard equations. You just have to remember to set up both possibilities. Subtract 1 from both sides to finish solving. In this case, x could be 1. If I subtract 1 from both sides here, x could be negative 3. Then I did the math over here, but if you can do the check in your head, it's fine. If I take a 1 and plug it in, 1 plus 1 is 2, and the absolute value of 2 is 2. Minus 4 is negative 2. This one checks. If I take a negative 3, negative 3 plus 1 is negative 2. The absolute value of negative 2 is 2. Subtract 4 and you get negative 2. Since both of those work, I'll put my and in between, and I'm going to box in my answers. All right, let's take a look at the last couple because there's some different scenarios here. Let's take a look at this one. We've got x minus 3 in absolute value. The absolute value of x minus 3 plus 4 equals 4. That already looks kind of weird. What happens when we subtract 4? We subtract 4. I get absolute value of x minus 3 equals 0. What does that mean? Well, it means the distance from 0 is 0. In other words, x minus 3, when I take whatever x value I have and I subtract 3, it sits right on the number line at 0. Remember also, we're supposed to, once you isolate the absolute value, you have to do two equations, once to the positive, once to the negative. 0 is neither positive nor negative. So this is a special case where I can go ahead and remove the absolute value bars, x minus 3. We're supposed to set it equal once to the positive and once to the negative, but 0 has neither positive nor negative. Oops, I forgot to remove my bars. Sorry, y'all. So this case, I only have one possibility. The distance from 0 is 0, and I don't have a positive or negative version of that number. So I can only have one equation to solve. I'm going to add 3 to both sides, and x is 3. That should make sense. 3 minus 3 is 0. That's the only number that's going to make that equal to 0 to where 4 equals 4. When you have an absolute value set to 0 after you isolate it, there's only one solution. There's just one possible solution, and that's okay. If it's a distance from 0, some number other than 0, you're going to have two solutions. If it is 0, you'll have one solution. And then finally, this last case. This last case here, I've got absolute value of x plus 2, then add 3, and that should equal 1. So again, our goal is to isolate the absolute value. That's easy enough with some algebra. We'll just subtract 3 from both sides. So I get absolute value of x plus 2 equals 1 minus 3, negative 2. So this time I got a negative on this side. Well, let's follow our pattern. Once you get the process, once you get the absolute value, isolate it, which it is. There's no addition or subtraction on either side. There's no multiplier in the front. Once we get it isolated, you can remove the absolute value bars and set up your two equations. X plus 2 equals negative 2, or you have to do the opposite. X plus 2 equals positive 2. So once to the negative, once to the positive. Let's solve this. If I subtract 2, I get x is negative 4. Over here, if I subtract 2, I get, oops, and I put an or in again, didn't I? We decided on and earlier. Like I said, or would work. Subtract 2 from both sides, x is 0. If you start getting lazy and not check your answers, it's going to come back to bite you, and here's why right here. Because watch what happens when I plug in a -4. I guess I'll show you. If I do, we're going to check it. If I do -4, plug it in for x into the absolute value, add 2, and then outside absolute value, add 3. That should equal 1. I'm going to put a question mark because I'm checking it. -4 plus 2 inside the absolute value is -2. We're supposed to add that to 3 and see if it equals 1. Again, I'm still checking, question mark. Absolute value of -2 is 2. And 2 plus 3 does not equal 1. That solution is a bad solution. That is an invalid solution. That's an invalid solution. Let's check this one. What if I plug a 0 in? Check. Let's see if this one works. So I already got one invalid here. That'd be 0 plus 2. Then add 3. Does that equal 1? It looks like we're going to get the same business here. 0 plus 2 is 2, and the absolute value of 2 is 2. Plus 3 equals 1. 5 does not equal 1. This solution is also invalid. So that one doesn't work either. You see how important it is to check your work? This solution doesn't work. This solution doesn't work. My algebra was fine. There's another problem with this. Here's my answer. There's no solution to this absolute value. There is no value for x that when I add it to 2, take the absolute value and add 3, do I get a value of 1? Here is my red flag right here. In this step, I should have known there was no solution because I've got an absolute value set equal to a negative number. Absolute value is distance, and distance cannot be negative, or distance from 0. Whenever you have and absolute values can't be negative. So if you isolate your absolute value and have it set equal to a negative number, that's invalid in mathematics. You're not going to have valid solutions. You're going to have no solution. So it's always a good idea to check your work. The ones above I did mentally. I did this on paper to show you. But you're going to come up with a situation every now and then when you have no solution. The only example I didn't give you, I'm going to kind of just draw it down here, is if you start with an absolute value and you've got a multiplier in the front. I probably should have made this an even number so it worked out a little easier. In order to isolate the absolute value, you undo multiplication in math with division. You simply divide both sides by 2 to isolate your absolute value. Got it isolated, then you're ready to rock and roll. X minus 1 equals 3 or x minus 1 equals -3. All right, that's the whole page, but again, you've got the video in case you need to go back and rewind and look at a problem, but there's some good examples for you. The next video I'm going to do is for the next set of notes, absolute value inequalities.